Now we have the claim that a conservative field is a gradient of another function, okay, or a gradient of a potential function. Saying that a little more clearly. And it's really pretty easy to prove that. A field is conservative if and only if it's the gradient of some scalar function. Okay. You can get the scalar function by integrating the conservative field, and you can get the conservative field by taking the gradient of the potential function. Okay. In any case, we want to show that the curl of a conservative field is 0. Okay, so well, a conservative field then is one that's a gradient of some function. F would be your potential function, little f. Gradient of little f is your big F field. Okay, there's your field. This, whatever this function is, if its gradient is defined on a region, then this function is conservative on the region. Okay, and this f then being the gradient of little f is just what? Derivative of little f with respect to x times I plus a derivative of little f with respect to y times j plus derivative of little f with respect to z times k. So now if we do the curl, well, let's write out the curl in the gradient in the determinant form. Here it is. And our function, of course, has components fx, fy, and fz. So we just evaluate the determinant and look at what happens. Okay, I gets multiplied by the determinant of this minor, which is partial of fz with respect to y, write that as fzy, minus partial with respect to z of fy. Okay? Well, look at that. The partial fyz is the same as fzy, isn't it? The order of your partials doesn't matter. We proved that a long time ago. So, that's going to give us 0. Well, how about that? Well, it happens with the j and k components as well. If you just write it out, you see that. You get fzx minus fxz. Well, fzx and fxz are identical, so when you subtract, you get 0, and here you get 0. So you get the 0 vector. So the curl of the conservative field is the 0 vector. Very easy to prove, but you want to be able to prove that. You want to be aware of that. Very important property.